Welcome to Mrs. Taylor's math class. Today I would like for you to practice with me dividing radical expressions. Now let's begin class. Here are your 6 problems. Pause the video. For question number 1, you have the square root of 8 divided by the square root of 100. So you would want to first look to see if either one of the radicals is a perfect square. In this case, 100 is. So the square root of 100 is 10. The square root of 8 is not a perfect square, but it does contain a perfect square as one of its factors. So the square root of 4 times the square root of 2 does equal the square root of 8, but the square root of 4 is a radical, so you would change that to 2, because the square root of 4 is 2, times the square root of 2 over 10. Now you have to simplify the fraction part, which is 2 over 10. And so let's do it down here. You would divide them both by 2, and that would be 1/5. Why did I put 15? Haha. 1/5. Let's do that again. 1 over 5. So your answer would be 1 over 5, but we're just going to put the square root of 2 over 5. We don't need the 1 because we are mature math students. And that's it. For question number 2, we have the square root of 6 over the square root of 27. For the square root of 6, it is not a perfect square, and neither is 27. But for 27, one of the factors is a perfect square. So we're going to rewrite this as the square root of 6 over the square root of 9 times the square root of 3. This is going to get me the square root of 6 up top. And the square root of 9 is 3 times the square root of 3. But I can combine these two right here. And so I can rewrite this as, we still have, like, let's say 1 over 3 times the square root of 6. Let's make it all big like that. Okay, stay with me. And so you have 1/3 times the square root of 2. And you know that's over 1, so you can rewrite this as the square root of 2 over 3. And you're done. For question number 3, you have the square root of 15 over 5 times the square root of 20. Again, the square root of 15 is not a perfect square, and none of its factors other than 1 is a perfect square. So we're going to leave it as is right now. But the square root of 20 does have a perfect square as one of its factors, which is the number 4. So I'm going to write this as the square root of 15 over 5 times the square root of 4 times the square root of 5. So let's take it step by step. The square root of 15 is here. This would be 5 times 2 times the square root of 5. Now let's keep going. Again, the square root of 5 and the square root of 15, I'm combining those together under one radical. And then I can combine the 5 and 2. So I get 1 over 10. And then I'll put this under one radical, 15 over 5. So I get 1 over 10 times the square root of 3. And so I can combine the 2. Look at this thing. And you get the square root of 3 over 10. And you're done. For question 4, you have 3 times the square root of 20 over 2 times the square root of 4. So here, I can, I know the square root of 4 is a perfect square. 20 has a perfect square, which is 2. Which is 4, which goes to the square root of 2. You know what I'm talking about. Okay, anyway, let's just do it. 3 times the square root of 4 times the square root of 5, that equals 20. And then you have 2 times 2. Because the square root of 4 is 2. That's where it comes from. This thing wants to solve for me. I don't need that. Can that feature go away? Okay. So now I have 3 times 2, because the square root of 4 is 2, times the square root of 5, all over 4. And so now I get 6 times the square root of 5 over 4. But of course, 6 and 4 can both be simplified to 3 over 2. So this would be 3 times the square root of 5 over 2. And you're done. And now that I look at it, guess what? I guess I could have done it like this. 3 over 2 times 20 over 4. And you get 3 over 2 times the square root of 5. Look at that. Another way. Now we're done. For question 5, 5 is not a perfect square. So for this one, you actually have to multiply by the conjugate. So let me erase this. So I'm going to multiply both my numerator and denominator by the square root of 5 because I want to get rid of the radical. So this is going to be 4 times the square root of 5 over the square root of 25, which simplifies to 4 times the square root of 5 over 5. And we are done. For question 6, 4 is a perfect square, but the 3 is not. So let's take it step by step first. Let's make this a 2 and then leave this as 5 square root of 3. We want to get rid of the radical in your denominator, so multiply by the square root of 3 for your numerator and denominator, and then you get 2 times the square root of 3 over 5 times the square root of 9. But you know that the square root of 9 is 3. So this is going to be 2 times the square root of 3 over 5 times 3. And to simplify it even further, you multiply 5 times 3 to get 15, and you are done. Thanks for watching. Don't forget to like, comment, share, and subscribe. Class is dismissed.